Very good morning to everyone. Today we are going to delve into a very important exam going topic, anesthesia machine. As very well said by Paul G. Barash, that anesthesia is not just a science. However, it is an art of precision and intuition. And we have achieved this precision in the field of anesthesia in the form of invention of Boyle's basic anesthesia machine, and with time we have progressed to most sophisticated anesthesia workstation, which has allowed us to deliver accurate and appropriate anesthetic agent with such a precision. So let us learn about more about the anesthesia machine and workstation. Okay. So the objective of my talk will be when and why was anesthesia machine invented? What are the components of anesthesia machine and what are the function of those components? What are the safety features? And then we will touch upon the differences between the anesthesia machine and anesthesia workstation. Then we'll also discuss about pre-anesthesia machine checkout procedure. As we all know, anesthesia machine and Boyle's, they go as synonymous. Anesthesia machine was first invented by Henry Edmund Gaskin Boyle in 1917. It was a modification of American Guathame apparatus, which was invented in 1912. However, Boyle was first to present the machine in front of the Royal Society of Medicine. So all the credit goes to Boyle's. Now the question is, why was the need for anesthesia machine why there was the need for the anesthesia machine? When the compressed cylinders came into picture, so there was the need of some frame where these cylinder could be mounted, and there should be some apparatus which can provide oxygen, accurately mixes the anesthesia gases and vapors, and enable patient ventilation as well as minimize the anesthesia risk. So this gave an idea for the invention of the anesthesia machine. Now we have moved on to basic Boyle's anesthesia machine to these sophisticated workstations. Anesthesia machine mainly comprises of pneumatic system. However, workstation comprises of both pneumatic as well as electronic or electrical systems. Now, when we go into details about the anesthesia machine components, the pneumatic component is divided further into high pressure system, intermediate pressure system, and low pressure system. And the electric components are comprised of master switch, power failure indicator, reserve power electrical outlets, circuit breakers, and data communication ports, etc. So when we talk about the high pressure system, it starts from the yoke assembly and ends at the pressure regulator. And intermediate pressure system starts from the pressure regulator to the flow control valve. The low pressure system starts from the flow control valve and ends at the machine outlet. So we'll discuss about it in detail. Coming to the high pressure system, as we have already discussed, it starts from the yoke assembly to the pressure regulator, and it comprises of a system where the gas are delivered at the cylinder pressure. So knowing the cylinder pressure, you should know that oxygen cylinder pressure cylinder has pressure of 2000 psi, and nitrous oxide has pressure of 750 psi. So high pressure system, when reaches into intermediate pressure system, this pressure is reduced to 45 to 50 psi. Before moving on to high pressure system, we'll just discuss briefly about cylinders. As I have said, there's a term called compressed gas. You should know what is the definition of compressed gas. The gas in the containers having an absolute pressure which exceed 40 psi at 70 degree Fahrenheit is known as compressed gas. The cylinders nowadays are made up of molybdenum steel, which have high tensile strength and lighter in weight and can accommodate more gas. However, in the MRI suites, the cylinders are made up of aluminum because they are MRI compatible. There's one more term called service pressure. You should know the definition of service pressure also. The maximum pressure to which the cylinder can be filled at 70 degree Fahrenheit is known as service pressure, and each and every cylinder should be able to withstand the pressure which is more than 1.66 times of the service pressure. Now, knowing the color coding of the cylinder is very important. We know that oxygen, the body of the oxygen cylinder is black and shoulders are white. Nitrous oxide is completely blue. Air, the body is black and the shoulders are black and white combination. Carbon dioxide is gray. Antonex is blue in color. The body is blue in color. However, the shoulders are white and blue. Helium is brown in color. This is the international color coding, which shows that oxygen is white in color and rest of the cylinder, the shoulder color differs. Now, every anesthesia machine part has some safety feature. Similarly, cylinders also have the safety feature. Whenever the pressure in the cylinder exceeds the dangerous level, the gases either should vent off or otherwise the cylinder will burst. So there is a safety feature so that the gas can vent off when there is higher pressure. These are ruptured discs. Whenever there is higher pressure, the disc will rupture and the gases will vent off. Fusible plug, it is a thermolabile plug which is made up of wood's metal. And whenever there is increase in temperature, ultimately the pressure of the gas will increase. This plug will melt and the gases will vent off and the cylinder will be empty. Then comes a pressure relief valve. You can see here in the picture, this shows the pressure relief valve. The flow in is from the cylinder to the valve. Whenever the pressure exceeds the dangerous level, this flow of gas will move this piston as well as the spring. Once this piston and spring will move, this pressure relief valve here, it will open and the gas will vent off. The advantage of pressure relief valve is only the till the dangerous level has passed on or a normal level of the gas cylinder has been achieved, the gas will be vented off. Rest of the gas will remain in the cylinder and this pressure relief valve is closed. Now moving on to the components of the high pressure system, I will enumerate the component and then we will discuss. Hanger yoke assembly, Borden cylinder pressure gauge, check valve assembly, pressure regulator. Now we'll discuss hanger yoke assembly in detail. You can see here this is a hanger yoke assembly. It has a body which is the principal framework of the supporting structure. Then there is a retaining screw. This retaining screw will hold the cylinder tightly inside the yoke assembly. And nipple, you can see here this is the opening. This is called nipple, from where the oxygen or any other gas, anesthetic gas, will enter from the cylinder to the machine. Then index pin. These are the pins and the holes, corresponding holes are seen in the cylinders. Woodlock seal. Here you can see this is a nipple and surrounding the nipple there is a washer which is known as Woodlock seal. It is made up of neoprene rubber which is surrounded by the aluminium ring. This here it is shown. And there is a filter beyond the Woodlock seal which will remove the particulate matter. Further downstream, if we will go, there is a check valve assembly which ensures the unidirectional flow of the gas through the yoke. Now here we'll discuss in detail about the pin index system. It was invented by Philip Woodbridge in 1952 and it ensures that the correct medical cylinder is hung to the correct yoke. The system consists of pins which are present on the yoke assembly and the holes which are present on the cylinder. So how does these holes are made? The holes are made over the radius curvature of 9 by 16 of the inch from the center of the port of the cylinder wall. The diameter of the pin is around 4 millimeter and the diameter of the hole is 4.3 millimeter. The length of the pin is 6 millimeter. Six pin positions are located at interval of 12 degrees and the seventh pin is located between the 3 and 4. Here you can see between the 3 and 4. So also remember the pin index of different cylinders. It is easier to remember in this sequence: air 1 by 5, 1 5, oxygen 2 5, nitrous oxide 3 5, and then we'll move on to 1 6 2 6 3 6. 1 6 carbon dioxide greater than 7%, 2 6 carbon dioxide less than 7%, 3 6 cyclopropane, 4 6 is of heliox, and antonox 7. So this is how you can remember the pin indexes. Now the question which you can be asked in the exam, can pin index system be bypassed? Yes, it can be bypassed if the pins are broken, damaged or corroded, or more than one Woodlock seal is used, then it will bypass the pin index system, and can lead to wrong cylinder can be mounted on the yoke assembly. Coming to the Borden's pressure gauge, what it is, you can see here that It is made up of copper metal, a flexible tube made up of copper metal, which is closed at the end. With a link system, it is attached to the gear, and from the gear, this is a needle pointer. So whenever the gas enters the Borden gauge, the flexible tube will move. Once it will move, it will through the link, it will move the gear, and the pointer will also move to show the correct pressure reading of the cylinder. You can see here in the Borden gauge, there is written use of no oil. The chemical name of the gas, oxygen, here is written, and this is a scale. The scale which is shown here, it should be around 33% more of the filling pressure of the cylinder. Now, the question which can be asked to you, is there anything specific in the making of the Borden gauge? Yes, there is something specific. It is covered of heavy glass in front and loosely fitted, heavy glass in front and loosely fitted tin at the back. Why it is done so? Because whenever there is high pressure and there are, if there is any chance that this gauge may rupture or may glass may break. So what will happen? The glass is so heavy that it will not be affected. However, the gas will pass from the loosely fitted tin from the back, and it will protect the anesthetist as well as the patient. So this is a safety feature. Now the question is, what is the difference between the oxygen or nitrous Borden gauge? The pressure which is shown in the gauges of the nitrous remains constant until all liquid nitrous evaporates, because we know that nitrous is stored in a liquid form. And initially there was no nitrous Borden gauge. It was introduced only through when Boyle's Mark III was invented. If the pressure you read on the gauge reduces below 750 psi, then you should be able to confer that all liquid has already evaporated and only gas is left, and the cylinder will empty in no time. Now moving on to the check valve assembly. Check valve assembly is very important. This is the nipple as we have shown previously. The gas enters from the nipple. Once it will enter, it will push the plunger, and once the plunger is pushed, the gas will enter from cylinder to the machine. However, if vice versa will happen, like from the machine the gas will come, this plunger will be moved back and no gas can enter from the machine to the cylinder. So what is the advantage? What are the function of unidirectional check valve? This is a question which can be asked in exam. It prevents transfilling. The cylinder which is having high pressure, the gas can pass from that cylinder to the cylinder which is having low pressure. However, because of this unilateral check valve, the transfilling can be prevented. It allows gases from cylinder to enter the machine, but not vice versa. Third, it allows replacement of the cylinder without loss of the gases. So these are the function. However, there could be malfunctioning of the valve. So don't take it for granted. Always you can tell the examiner that yoke should not be left vacant and yoke plug should be used to prevent any mishap or loss of the gases from the cylinder or prevent transfilling. Okay. Now moving on to the pressure regulators. These are the pressure regulators. These are factory preset, and they convert the variable high pressure into the constant low pressure. The pressure regulator reduces the cylinder pressure like 2000 and 760, as we have discussed, that of oxygen and nitrous, to 45 to 50 psi. Force is equal to pressure into area. So force here is constant, and if the area will increase, the pressure will reduce. So you can see the gas is coming here, and suddenly it enters to the larger area, and this will lead to reduction in the pressure, and ultimately the gas which will be going from the outlet will be of low pressure. This is the principle of the pressure regulator. So the question again is, why was there need for pressure regulators? There was need for pressure regulator because it will prevent damage to the flow control valve, as high pressure can damage the flow control valve. It will minimize the trauma to the patient's lung. And also, since the variable high pressure is converted into constant and low pressure, it will prevent the readjusting of the flow control valve to maintain a constant flow. One more reason is there that whenever the cylinder is used, the pressure in the cylinder will keep reducing. If the cylinder pressure will keep reducing, there should be continuous readjustment at the flow control valves to maintain the constant flow, which can be prevented because of presence of pressure regulator. Now, what is master and slave mechanism in pressure regulator? The nitrous oxide regulator is slave regulator. You can see these are the nitrous oxide regulator, these are the oxygen regulator. Why it is said so? Because there is connection between the oxygen and nitrous regulator, and if there is no flow in the oxygen line, there will be no output from the nitrous oxide. This is an important preventive measure so that hypoxic mixture is not delivered to the patient. Now the question is it foolproof master and slave mechanism? No, it is not foolproof. Why? Because it is flow dependent. If by mistake a wrong cylinder has been attached or even a wrong pipeline has been attached, then the master slave mechanism or the regulator will not identify the gas. It will just identify the flow, and there are chances of delivery of hypoxic mixture if the wrong cylinders are attached. And also, if the flow is cut down downstream of the master slave, the hypoxia mixture can be delivered. So it is not a foolproof mechanism. Now moving on to the intermediate pressure system, the components of machine which receive gases at reduced and constant pressure of 45 to 60 psi comes in the intermediate pressure system. So intermediate pressure system arise from the pressure regulator, and it ends at the flow control knobs. These are the components of intermediate pressure system: oxygen failure alarm system, oxygen flush, pipe inlet connection, pipeline pressure gauges, oxygen pressure failure devices. There's a master switch, auxiliary gas outlets are present here beneath, which are not seen here. Second stage pressure regulator, it is not present in all the machines, but few machines have second stage pressure regulator. Now we'll discuss all the components one by one. Oxygen flush, which is normally labeled as O2. And you should remember that oxygen flush is independent of the master switch. So you can see here from the oxygen pressure regulator, a direct tubing is coming to the common gas outlet. So here also you can see this is these are the oxygen regulator, and a direct tubing is coming towards the oxygen flush. Okay, so that is why whenever you will push the button of the oxygen flush, the pressure which will be provided will be 45 to 50 psig, and it will give a flow of 35 to 70 liter per minute. Now moving on to the pipeline inlet connection. Pipeline inlet connection, what it is? It is basically either be wall mounted or on the pendant. These are the entry points of the gases from the pipeline or manifold to the anesthesia machine. Each inlet also, here also it contains a filter and unidirectional check valve. So what are the safety features? What are the safety measures for connecting the pipelines to inlet and anesthesia workstation? This is very important. Just like pin index, there are safety features in the pipeline also to prevent the connection of the wrong gas to the wrong inlet. And these gas inlets are specific to each gas. These are labeled, colored, and pipeline hoses are also color coded. So what are the safety features? Let's see. This is diameter index safety system, just like pin index safety system. There are the components of these pipelines contain a series of increasing and decreasing diameter, which prevent wrong pipeline to be connected to the wrong hose to be connected to the wrong pipeline inlet. So this is a safety feature so that the correct hose is connected to the correct pipeline inlet. The second, this is mainly used in US, and this Omeda quick connector is also mainly used in US. When we talk about Europe, there the safety feature is NIST, non-interchangeable screw thread connector. Shredder quick connector is also used in UK and UK territories. So this is, you can see this is Detex Omeda quick connect. In our hospital, we the machine pipeline inlets are Datex Omeda Quick Connect. Just you should go to your hospital inside the OT, find out what kind of connect has been used in your hospital pipeline system. These are the photographs showing diameter index safety system, non-interchangeable screw threads, shredder quick connect, and DIN. This is used in Germany. So these are all the safety features. Now moving on to pipeline pressure gauges. Pipeline pressure gauges, they are used to monitor the pipeline pressure of each gas. They are usually on the panel on the front of the machine, and they are also color coded as well as labeled. The chemical name of the gas will be written. The pressure you should check while checking the pipeline. You should check the pressure. It should show between 50 to 60 psi. These are analog type, and this is digital. So when now the question arises, in case while checking the cylinder, if you leave the cylinder open, the gas will enter from the cylinder or from the pipeline inlet. So the answer is gas will enter from the pipeline, because pipeline pressure is higher, around 60 psi, than what pressure is coming from the pressure regulator, which is 35 to 50 psi, or you can say 45 to 50 psi. So the question might come into your mind, since the gas is going through pipeline only, why there is a need of closing the cylinder? It is important to close the cylinder after checking the cylinder. Otherwise, what will happen? By chance, there is a drop in pipeline pressure. The gas will start flowing from the cylinder. And once the cylinder, the gas, oxygen from the gas cylinder is also empty, the alarm will start ringing. So the once the alarm will start ringing, you will have no backup because your cylinder is also empty. So always after checking the cylinder, please turn the cylinder off also. Now moving on to oxygen pressure failure devices. There are two types: oxygen pressure safety devices, or oxygen fail-safe valves, and oxygen supply failure alarm. These are instituted in the machine to provide protection against the hypoxic mixture to be delivered to the patient. So you might have heard about this Ritchie whistle, which is asked in exam also. It is an oxygen failure alarm. You can see when the machine is switched on, there is a reservoir which will be filled with oxygen, and when the oxygen pressure will fall below 30 to 35 psi, the gas in the reservoir will pass a clarinet sound or reed sound that will be sounding like an alarm, and this alarm should enunciated within 5 seconds, and it should not be possible to disable this alarm. The alarm will can be disabled after 120 seconds, or it will automatically disable if the pressure drops down below 6 psi. Now moving on to the we are talking about fail-safe valves. There are different valves in different machine. In Detex Omeda, it is pressure sensor shut-off valve. It works on the threshold principles. What does it mean? This valve will operate on the threshold manner. It will be either open or closed. So you can see here, when the oxygen supply pressure is greater than 20 psi, this diaphragm will move the piston above, and the valve seat will also move above, and the orifice will open, the nitrous oxide will flow. However, when the oxygen pressure will fall below 20 psi, the diaphragm and piston will be moved back. The valve seat will close the orifice. There will be no flow of oxygen. Complete shut off of the nitrous oxide will occur if the oxygen supply pressure is less than 20 psi. This is the pressure sensor shut off valve, which works on threshold principle. The other one is oxygen failure protection device, which is present in Draeger machine. This is based on proportionating principle. What does it mean? The pressure of all the gases, which is controlled by oxygen pressure failure device, will decrease proportionally with the decrease in the oxygen pressure. Okay, you can see the oxygen pressure at 50 psi. The piston here will move up. The valve seat will also move the nozzle, and the nitrous oxide is uh, the flow of nitrous oxide is also at 50 psi. And if the oxygen pressure reduced to 25, the piston will move back. The valve seat will also reduce the orifice, and proportionately, and then see here the output of the nitrous oxide is 25 psi. Similarly, in proportionating manner, once the oxygen will reduce, nitrous oxide will keep reducing. Here it is completely shut off. There are auxiliary outlet also. You can see here there are two auxiliary outlet. The function of these auxiliary outlet is they are as the extra oxygen outlet. They provide oxygen for the movement of the bellows in the ventilators and can also provide high frequency ventilation for time. Now, few of the machines have second stage pressure regulator, as I said before. This additional pressure regulator is present just upstream of the flow adjustment controls. It will reduce the pressure to around 26 psi of nitrous oxide and 14 psi for oxygen. It will provide more constant and low pressure and prevent further damage. It will prevent the damage to the flow control valves. Not all anesthesia machine incorporate this device. Now moving on to low pressure system. Low pressure system is from flow control knobs to common gas outlet. The pressure here is just above the atmospheric pressure. So low pressure system, the part of the machine which is downstream of the flow meters, in which the pressure is slightly above the atmosphere. The components of this low pressure system are flow meter assembly, hypoxia prevention safety devices, unidirectional valves, pressure relief devices, and common gas outlet. We'll discuss each and every component one by one. Flow control assembly comprises of flow control valve and flow meter subassembly. Flow control valve is also known as pin valve or needle valve. It has control knob, stem, and seat. So flow control knob, what does they do? They regulate the flow of oxygen, air, and other gases to the flow meter. There is one flow adjustment control for one gas. Okay. Now, how does it function? Flow control knob, the mechanical flow control valve utilizes a stem with fine threads. When it is moved counterclockwise, the orifice between the pin and the seat will be open. See, from here the oxygen will enter, and the pin and the seat, there will be opening in between the pin and the seat, and the flow will enter, gas flow will enter the flow meter. If it is turned clockwise, the flow will stop because the opening between the pin and the seat will be closed. Now, what are the safety features of flow control knob? Flow control knob is color coded, it is labeled, it is touch coded, and there are also stops of for the off and maximum flow positions. You can see here. These are the wall stops. It is present at the maximum on and maximum off position. Okay. So these are color coded, labeled, the chemical name will be written. Touch coded means like when you will touch the flow control valve, you can feel. See here, this is white color, oxygen is written. They have flutes which are wider. This is blue color, and the flutes are very narrower. And sometimes this is also conical. So color coded, chemical name is written. These are touch coded, as well as there are stops present at the off and maximum position. So what is the role of the stop? It will prevent the damage to the fine needle when it is in complete off position. When it will be in complete on position, it will prevent the disengagement. So if there is disengagement, there will be loss of the gas out of the flow meters. Different types of flow meters. There are three different types of flow meter. Traditionally, as we have seen, the control is by needle valve and display is glass tube. Transitional is hybrid. The control is by needle valve, but the display will be electronic. In electronic, the control as well as display will be electronic. Now, what are flow control tubes? These are made up of porosolite glass pyrex and known as Thorpe's tube. These are the vertical tubes with internal taper. Its smallest diameter will be at the bottom. The tubes have different lengths and different diameters for the different gas, and each gas has a specific tube. Now moving on to the flow rate through the flow meter. The flow rate through the flow meter depends on three things. The pressure drop across the constriction. The pressure drop across the constriction is constant throughout the flow tubes. The size of the annular opening, which varies, and physical properties of the gas. At low flows, like here you can see, at the low flows, when the gas will pass, it will be pass around the float, it will be around, it will pass in a laminar flow. And the according to Poiseuille's law, the flow will be governed by the viscosity. At the higher flow, the annular opening become more wider and the flow will be turbulent. This will be governed by the Graham's law, and the flows will be governed by the density of the gas. Now coming on to what are the safety features of the flow meter assembly. It is leak proof, the float spins freely, the anti-static coating is present, which is of Croxting. The fluorescent backplate, even when there is no light, then you can see the flows because of fluorescent backplate. There are O-rings, or which are also known as neoprene washers at the both end of the flow meter, so that it will prevent the escape of the gases. Now coming on to the arrangement of the flow tubes. They are connected in series, and the oxygen is always present downstream of the gas. Downstream, the meaning of the downstream is towards the common gas outlet. So just try and understand, if it is oxygen is upstream and there is breakage in some tube, the oxygen is coming from here and it will get mixed or lost here. The ultimate concentration of oxygen will be very less. However, if the oxygen tube is most downstream and there is a breakage in other flow meter, then the oxygen concentration which will be provided to the patient will be higher. Though it will not prevent 100% hypoxia, but it will be helpful in preventing hypoxia if it is placed most downstream. The other features of the flow meter, safety features of flow meter assembly are hypoxia prevention safety devices. These are the following. First, minimum mandatory flow, oxygen flow. There are machines where flow meters on some machines have a minimum oxygen flow as soon as they are switched on, which is around 50 to 250 ml per minute. There's a link system, which is known as proportionating system. You can see there are 14 sprocket fixed on the nitrous control knob and 29 sprocket fixed on the oxygen control knob. And this arrangement automatically will intercede to maintain a minimum 1:3 ratio of oxygen to nitrous. So this is also a safety feature. The other one is sensitive oxygen ratio controller, which is present in Breger Fabius. What happens? It will guarantee the minimal flow of the FiO2 of 21% by limiting the nitrous oxide flow. If FiO2 percentage will reduce below 21%, nitrous oxide flow will be completely stopped. Now moving off to the pop-off valve. There's a valve present here. You can see it is downstream to the vaporizer. Why it is present? Whenever there is increase in pressure more than 5 psi, then this pop-off valve will open and the excess gas will be vented off. This will help to prevent damage to the vaporizer and flow meters. It can happen whenever there is a obstruction at the outlet or pressure is increased because of any other reason. This pop-off valve will prevent the damage to the vaporizer as well as the flow meters. Now, scavenging system. Scavenging system is an important feature of anesthesia machine, especially modern anesthesia machine. The waste anesthetic gases and volatile agents are subject to control of substances hazardous to health and the Health and Safety at Work Act. That is why scavenging system is important to be there in the anesthesia works machines. There are two types of scavenging system, active as well as passive. Now, we have already discussed few features of anesthesia workstation previously itself in the slides. Now we'll discuss further few changes which are incorporated in anesthesia workstation. First of all, you understand what is workstation and how it is different from the machine. According to the ASTM, anesthesia workstation should contain 4 components. One, anesthesia gas supply devices, ventilator, protection devices, and monitors. Then it becomes an anesthesia workstation. It also provides more accurate and correct tidal volume, which is possibly because of many factors, but mainly 2 factors which has been incorporated in different machines, like fresh gas compensation and fresh gas decoupling valve. It also provides better protection against the barotrauma because of presence of pressure sensor, pressure control ventilation, APL valve, preset electronic inspiratory limits. These workstations also provide low flow capability because of smaller circuit volume, which is around 2.5 liters versus 6 liters previously, less circuit leakage, and return of sample gas to the circuit. There are better safety features. There are many better safety features. The most important is oxygen analyzer and E2O2 concentration can be measured. Now, just a few words about fresh gas decoupling device. What happened? Fresh gas decoupling device, the valve, what does it do? It prevent addition of the fresh gas flow to the ventilator derived tidal volume. Thus, it will ensure the accuracy of delivered tidal volume at the same time preventing barotrauma and volutrauma. How does this happen? You see in this picture. During what is happening? This is inspiration. What is happening during inspiration? The fresh gas flow is moving from here. However, this is the decoupling valve which is closed. Fresh gas flow will come here, then it will go through the soda lime into the reservoir bag. The reservoir bag will expand. And what is happening at this end? The ventilator piston is moved. The gas which was stored here above the piston will deliver the already set tidal volume accurately to the patient. Okay. And this fresh gas flow is not added to this tidal volume, and it make the tidal volume which is delivered to the patient more precise. However, what happens in expiration? Expiration, you can see the lung is collapsed, patient lung is collapsed, the expired gas is passing through the expiratory valve. What happens here? It will create a negative pressure in the ventilator piston and the decoupling valve is open. So the gas which was accumulated in the reservoir bag will now move here and will enter the ventilator just above the ventilator piston, and this gas will be utilized in the next cycle of the inspiration to provide the precise tidal volume. This is the function of fresh gas decoupling valve. Now, what is fresh gas compensation? Volume and flow sensors provide feedback which allows the ventilator to adjust the delivered tidal volume as the set tidal volume, even if there are changes in the total gas flow. These two features are very important to provide the precise set tidal volume to the patient. Now, important thing is you should always do this pre-anesthesia machine checkout, and it will be definitely asked in exam to you. In 2008, ASA recommends 15 separate items to be checked or verified, which should be done at the beginning of each day or whenever a machine is moved, serviced, or any vaporizer is changed. So, if we'll discuss item 1, it is very important to check the auxiliary oxygen cylinder and manual ventilation device, that is ambu bag, whether it is available, as well as check the functioning, not only availability, check the functioning of the device. Then secondly, check the suction, whether it is adequately working or not. Third, turn on the anesthesia delivery system and confirm that the AC power is available, battery backup is there. Fourth, verify the availability of required monitors, including alarms. Then verify the pressure, check the oxygen cylinder pressure, which are mounted on the anesthesia machine. In the workstation, they are mounted at the backside. Check the oxygen cylinder. Then move on to the gas pipeline. Check the pipeline pressure. It should be greater than 50 psi, and do the tug test also. Verify that the vaporizer are adequately filled and properly closed. Then you have to do the universal leak test to check that there is no leak in the low pressure system. Test the scavenging system function, calibrate the oxygen. It has to be done daily, remember that. Verify carbon dioxide absorbent is fresh and not exhausted. Perform breathing system pressure and leak testing. Then to verify the gas flow properly during the breathing circuits, both during inspiration and exhalation, here you have to do the check of the breathing system while manually ventilating and when on ventilator. This can be done by double back test also. Document the complete checkout procedure. Then confirm the ventilator setting before delivering the anesthesia, like if you are taking a pediatric patient, check the ventilator setting are put on pediatric, uh, compatible with the pediatric patient. And if you are taking adult patient, you should check the ventilator setting, then anesthesia timeout. The similarly, in a checklist list of anesthetic equipment was released in 2012 by the anesthetists of Great Britain and Ireland. And this is more or less same as what we have discussed about the ASA 15 component checklist. You should go through this checklist. So thank you. Be confident when you walk in the examination hall. Best of luck. And if any query, any question, the session is open for the questions.